Hello everyone, and thank you for tuning in to this presentation. My name is Ricardo Mendes, and I'm here to present our work, Effect of User Expectation on Mobile App Privacy, a field study. I'm going to start with a brief introduction on privacy in mobile devices, then talk about the methodology that we took on this field study, and then show our analysis on expectations and privacy decisions. I'll finish with a brief summary and future work remarks. So, as you probably know, privacy in mobile devices is mostly controlled through permission managers. In the earlier days, we had install time permissions. And with install time permissions, a list of all the permissions required by an application would be listed or presented to the user at install time, and the user would either accept all permissions or refuse to install the application. Currently, we have runtime permissions, and with runtime permissions, the first time an application tries to access a sensitive resource, it has to ask explicitly authorization from the user, and the user can either deny or allow this access. If the user denies a particular permission, then the next time the application tries to access this resource, it will have to ask it again. If the user allows this permission, then the next time the application tries to access the resource, it will be automatically granted or allowed. We've seen some latest improvements with the newest versions of Android. So for instance, we now have location obfuscation, which allows to give an approximate location instead of the exact precise one. We have the option to use while using the app, which allows the permission while the application is running. And this is true for the location, camera, and microphone permissions. We also have the option to use only this time, which grants the permission single use. And auto reset when unused, which means that when applications are unused for a few months, all permissions from that application will revert back to the default denied state. Now, runtime permissions allowed for finer-grained control, as each permission can be managed independently of the others. It allows to contextualize permission prompts by the needs of the applications, as each permission is requested at runtime. And for the inclusion of developer explanations, which allow to better justify the needs of the application. And therefore, given these advantages, users have reported being more in control of their privacy. Now, the problem with this model is the number of automatically accepted permissions. In fact, there are hundreds of automatically accepted permissions, and these violate contextual integrity. By this, I mean that they violate the personal preferences of the user at each context at which they are being automatically accepted, as this context might be different from the one where the user first accepted the permission, and therefore these contradict user expectations. This is the summary of contributions of this work. We've collected over 65,000 privacy decisions and the respective expectations at each surrounding context from 93 participants. We make this dataset available to the research community, so if you're interested, please reach out to us. We uncover a strong misalignment between app practices and the expectation of users. Our data has revealed that almost 50% of all requests is unexpected to users. We also see that privacy decisions see the strongest correlation with user expectation. In fact, expected requests are allowed 90% of the times, whereas unexpected requests are allowed only less than 40%. We've also seen that the Android 9 default permission manager would have resulted in privacy violations 15% of the time. That is, from the 65,000 privacy decisions that our users answered, our users explicitly denied 15% of these that would have otherwise been accepted by the default permission manager, and therefore this would have resulted in privacy violations. The methodology taken in this work is as follows. We've recruited participants through the word of mouth and emailing lists from the university, and the first step would be to install our application called Apps Retriever. Now, Apps Retriever would send the list of personal applications in the phone of the participant to our server. We would use this list to install all the participants' applications in the campaign phone alongside with our naive permission manager. We would then borrow this phone for a period of 1 week, during which our naive permission manager would intercept and collect permission decisions. Naive permission manager works as follows. So every time an application would try to access a sensitive resource, so in case of the image we have Telegram trying to access the storage permission, our naive permission manager would intercept this call and would present the following dialog to the user. So in this case, Telegram is trying to access the storage permission, and the user would be able to either deny or allow the permission, and he would also have to fill in his current location and also answer the question, for what you are doing with the phone, is this request expected, with yes, no, or don't know. Okay, at this time of the interception of the permission request, we would also collect information about the requesting application, which would be the name and the category of the application as given by the Play Store. We would also collect the permission data, which would be the name and the group of the permission, and information surrounding the phone state. And this could be geolocation, plug, dock, call, screen, state, and network connections, and apps running in the foreground and the background. We'd also collect data about the user context, not only the semantic location from the input, but also the current local time, and if the user is in an event according to their calendar. And then we would collect the expectation, which is the question to the which is the answer to the question, for what you are doing with the phone, is this request expected? We had a total of 93 participants, of which 64% were students, 71 were between 18 and 24 years old, 57 had an IT background, so they were either studying or professionals in this area, and therefore our data is biased towards young adults with technical expertise. So this is one of the limitations of our work and dataset. We've collected over 2 million permission requests, and this corresponds to an average of around 800 requests per day or 35 per hour. And these numbers actually tell us that it's unfeasible in practice to request from the user his own personal decision. Or in other words, ask on every request is actually infeasible in practice. Of these 2 million permission requests, 65,000 permission requests were answered by our users. Permissions that were not answered by our users were either timed out or cached response, because we would cache the response of the user for 30 minutes and replay the same message should the application require so, or they were either timed out or dismissed. Now, from this data, from the 65,000 user answer requests, we've seen that users allow approximately 2 out of every 3 permission requests. We've seen that 46% of requests were unexpected, and this shows a strong misalignment between apps practices and the expectations of our users. We also see a strong correlation between privacy decisions and expectations. So we see in this graph is the privacy decision to either allow or deny the permission for each of the values of the expectations. And we can see that expected requests are allowed almost or actually over 90% of the times, whereas unexpected requests are allowed less than 40% of the times. So as you can see, the expectation of the user has a strong impact on the decision to either allow or deny a permission. But in fact, privacy decisions and expectations are strongly vary with the requested permission and app category of the requesting application. And we omit these plots because there's no time in this presentation to show you, but I invite you to read the paper. Now, we've measured the amount of requests that would have been allowed by the Android 9 permission manager that our users explicitly denied, and this corresponded to 15% of the 65,000 user answer requests. Therefore, this corresponds to privacy violations, and 15% of privacy violations is actually a quite high number. Now, one of the things that was unexpected to us in this work is that our data reveals that the visibility of the requesting app actually has limited impact on the privacy decision. What we've seen was that users allow 68% of visible requests, or requests that come from visible applications, while allowing only 62% from background apps. So 68% to 62% is actually a slower difference than we were expecting. But what we've seen from the data is that visibility actually has a strong influence in the expectations of users, as 60% of requests originating from a foreground running application are expected, while only 34% of requests coming from an invisible application, an application that is running in the background, is as expected. Another interesting result that we found is that expectation and its importance in privacy decisions is strongly personal or strongly subjective to the individual. And we're going to see a plot that shows exactly this. So what we can see in this plot is actually the average grant result. So whether the users allow permissions or deny permissions, and the color give us the average grant result for each of the expectation values. So we have expected, unexpected, or unknown for each of the users. So each column is a user, okay? And from this plot, what we can see is that most users strongly follow their expectations. And in fact, if you look at this rectangle, we have most of the users have green in the expected value and red in the unexpected value. And this corresponds to users that allow most or all permissions when they expect the requests and deny all or most permissions when they do not expect the request. Another observation is that some users mostly disregard their expectations. Now, this is a smaller minority, but we see that some users deny almost all permissions regardless of their expectation, and some other users allow all permissions regardless of their expectations. Now, there are also selective users whose expectation has some impact, but also consider other factors. And we can see those by this square here, where some users, so most users do mostly allow expected requests and mostly deny unexpected requests, but also consider other factors, as they don't always allow expected requests, nor do they always deny unexpected requests. Now, one of the things that we can do with the expectation of the users is actually to enhance the prediction of privacy decisions or to develop automated privacy decisions. And we actually have a paper on this that is currently submitted on enhancing the user privacy in mobile devices through the prediction of privacy preferences. And we had a recently accepted paper which is similar to the previous one, but it uses also federated learning in order to preserve privacy even against the entity that collects these privacy decisions and builds these prediction models. So, in summary, for this work, we have collected 2 million permission requests, of which 65,000 were user answered, and from this data we've shown that there is a strong misalignment between app practices and user expectations. We've shown that privacy decisions strongly correlate with expectancy, as 9 out of 10 expected requests are allowed, and expectancy is strongly subjective to each individual, the requested app category, the requested permission, the app category of the requesting application, and contextual features such as the visibility of the requesting application. Now, Android 9 would have violated the user privacy in 15% of our user answer requests, which is a number that can be reduced as shown in the papers that we have currently submitted. So as future work, we want to analyze the impact of the COVID-19 on the dataset, because in our campaigns we always had some limitation regarding the context, the richness of context that we could collect due to mandatory quarantines. We also want to use the user expectations for the prediction of privacy decisions, and this is ongoing because we already have some outputs and the papers already analyze this feature. And one of the challenges here is that expectation requires input, and therefore one of the things that we still want to do is to try and predict the user expectation through machine learning, and then use this estimation of the expectation to then try and predict the privacy decision. Because, as always, we want to reduce the amount of input that we require from the user in these automated solutions. So we'll be sharing an anonymized version of the dataset to academic researchers, and we also have our naive permission manager publicly available. So if you're interested in any of these tools, please reach out to us either through our email or through our website. Thank you very much, and if you have any questions,